videos. Back in my garage, or as my wife calls it, the toy room. More on cranks. Okay, in the last episode we talked about some of the characteristics of conrods and stroke and stuff. This one we're going to talk about the what the actual rods are made of, basically, in this last episode. So you've probably noticed that most of your rods have got this sort of bronzy coloured coating on them. Now this is because these forged rods are mainly made of steel with some other added metals involved, what they add to them. But when they harden them and do the heat treatment on these rods, they first copper plate them, because if they don't copper plate the rod becomes too brittle. Because the hardening purpose, they want to harden the surface where the bearings run. So the inside surface of the big end and the inside and this inside surface for the small end needs to be much harder. So in order to surface harden those areas, but without hardening too much the actual conrod, they need to copper coat it. So it's copper plated, and then it goes through the heat treating process. And then it's annealed in an oven. They anneal them later in an oven, and that's why we have this copper coating on our conrods. Okay, now it comes down to the webs themselves. Now the webs can be made by forged webs, they could be cast webs, they could be machined from billet. But forged webs will be the strongest, because that makes the property of the metal forged is much better, because the grains of your metal all go in the same direction as the forging, and therefore increases strength rather than going in any direction whatsoever. But it's very, very difficult on each of these cranks that are made that we're buying to find out what the metal's made of, what the process is, what it was made to, what the Rockwell is of them, how hard the material is. Very, very difficult. They don't give away information, so we're sort of working almost blind. So what you can do, you can use a Rockwell file, which you get a set of files, the varying hardness of different Rockwell, and then you can test somewhere where you can't see, obviously, maybe on the inside of the web, how hard the material is, by going up different sizes of Rockwell file until it actually starts to scratch the material. Then you know that's the hardness of it, and it will give you the degree of hardness of the webs. So we're kind of working with that information, because a lot of these crank manufacturers, they don't seem to give you any specifications of what materials, what specs they're using. They don't give you anything, as far as I can see. They just say, welcome to SIP Racing. This is the sport crank. Whoop, ha. And this is the race crank. Now the information. Thank you. We need to know what it is made of, what the bearings are, what the conrod's made of, what the webs are made of, what's the strength of the material. Give us something, for Christ's sake. Right, while we're here, I'm going to show you a little snippet of what I'm doing with this TV175 build. It's about the sprockets and gearing. Let's have a look. Okay, on the TV175 build that we're doing, it's got the original TV175 box in it. So the gearing on that standard is 4.82 final ratio, so with a 15:46. So what we've done, we've changed this. We've gone for a 47 on the back, and we put a 14 on the front, changing our final drive to 5.28, which is a far more sensible gear ratio for this 175 motor. I mean, the 175 original gearing is really, really tall. I mean, you hit a hill and you're getting off and pushing, basically. Okay, what we've got is a 14 tooth, 47 tooth, and an 80 link chain. And over here we're running on the original, it's a 46, 15 and an 80 link chain. So the final drive is 4.82, and on this side it's 5.28. So we've gone down to 5.28. That's a far better one instead of the 4.2. So this is far more sensible. The only thing is, when you fit these 14 tooth sprockets on the front, yeah, we'll just have a little zoom in and have a look at that. Not that close. Is that the chain runs into a machine section that's been cut out in the sprocket, and when you fit your cush drive onto it, it literally hits the chain. This high point here bashes into the chain as the chain goes round. You see, the chain overlaps into this piece here, so it touches it. So every time you chuck, this spins round and hits the chain, it's literally knocking the chain and damaging the chain. So you need to machine a bit back off these raised bits here, so it doesn't damage the chain. Don't worry, it's not going to slip round. But if you don't, you will destroy your chain very, very quickly. So that's a little snippet on my 175 build, and a little tip not to fit the 14 tooth without modifying this part of your drive. Modifying the drive. So what you reckon, did that one come out all right? The lighting and everything, you think it was okay? Yeah. Now, the other rods that you maybe have seen on some of our more modern cranks that we've been buying recently, look quite shiny and nice and polished and everything, and that's basically, they're a completely different material. This is a molybdenum alloy, which naturally much tougher tensile material. It's very resistant to wear, it's very resistant to corrosion, and it also has very good properties for a conrod. Fantastic properties for a conrod. This type of conrod is 26% stronger than your other normal forge conrod. Forge, chrome alloy, molybdenum rod. So that's why this rod can be lighter and still remain stronger and more resistant to wear on your bearings. So in other words, it's going to simply outlast this rod anyway. Okay guys, don't forget to leave some comments below. If you want any more questions about cranks that you want to know about, any technical stuff, I might be able to fish something out. Other people might be able to help by giving us some more information below, like some of the big companies maybe can give us some information on their cranks and how good they actually are. Or do we just have to speculate all the time? Thanks guys, see you later.